Okay, this is Walter Rudin's Chapter 1, Problem 1. If r is rational and r is not 0, and x is irrational, prove that r plus x and r times x, both of those are irrational. So if you add these together, an irrational plus a rational, is that somehow going to be a rational number? No, it's going to be an irrational number. If you multiply these together, is that somehow going to be a rational number? No, it's going to be a irrational number. And here's the proof. Here's a proof. So first we're going to say that r is going to be an element of the rational numbers. Okay, I already told us that. But also, r is going to be in the form of a over b, where a is non-zero and b is non-zero. This right here. So then what we're going to do, so this right here is the r plus x. We're going to prove that this is irrational first. So it's going to be proof by contradiction. So we're going to assume something that is false. R plus x is rational. So that's going to be something like c over d, some rational number. Then what we're going to do is we're going to take the irrational number, put it on the left, put all the rationals on the right. So c over d minus r. And r is nothing but a over b, so we're just going to use replacement and do x is c over d minus a over b. So you can see right away that this is a rational number, right? And this right here is an irrational number. So we already have a contradiction without working too far. But to make it a little bit better, we're just gonna combine these fractions. So x is cb over db minus ad over db. X is cd minus ad all over db. So this right here, after you work it all out, it's going to be an integer. This right here is going to be an integer. This right here, and this is non-zero. And we could even put that up here. Since r, well, we could say that r, well, I mean c and d do not equal 0. Okay. So this is right here. It's going to be an integer. This is going to be an integer. This is going to be a rational number that does not equal a irrational number. It says right up here. X is irrational. So this is where we get a contradiction. Okay. So now what we're going to do is we're going to assume Rx, that's going to be E over F this time. And we're going to do the same thing. We're going to put the irrationals on this side and the rationals on this side. So E over F R. And R is nothing but A over B. So X is going to be E over F times A over B. So then X is going to be BE over FA. And again, this is going to be an integer. This is going to be an integer. And what we're going to get is a contradiction because this right here is a rational number. This right here is an irrational number. Contradicting this up here. we go. Contradiction.